All right, hey everybody, and welcome back to this is chapter 12. This is the first time we've done this semester where we've had to cut a video in half. But this is just a long chapter. There's a lot of interesting things to talk about, and we're almost done talking about the decision-making aspect of this, and we're going to start talking about reasoning in the for the second half of this video. So let's look at some of the other heuristics. If you haven't watched part 1, definitely check that out, because we start talking about what heuristics are. They are mental shortcuts that kind of allow us to make decisions very effectively. They are, for the most part, governed by system 1, which is that intuitive thought process that we have. And we just talked about the representativeness heuristic, which is how whenever you are given some information, you initially try to base your judgments on that information, thinking that it is relevant to the decision. And we talked about examples where it wasn't. So here we're talking about the availability heuristic. Availability heuristic is super interesting because it's another one of those things where you can kind of see it all around us, and once you kind of notice it, it's hard to unnotice, which is kind of funny whenever you look at the definition of what it is. So the availability heuristic is how our decisions are kind of affected by things that we have seen recently. So if you've ever heard the phrase recency bias, this is not that different from a recency bias, where you tend to overvalue things that have happened recently. But the availability heuristic is whenever we are making judgments about how often something occurs, we tend to think about recent events, and we judge our estimates on those recent events. So basically, we say that things that just happened are more probable than they would have been if they hadn't already happened. So let me give you this is an example that you would find in a laboratory. I'll give you some applied examples on the next slide, but for here, let's just look at kind of the basics. So, for example, are there more words in the English language that start with the letter T or start with the letter K? So I want you to just take a guess. And you might be able to see my dogs playing in the background, because between this video and the last video, I took them on a WALK, and they have a lot of energy. Which is it? Start with T or start with K? The best answer here is, drum roll, is that it starts with T. There are more words in the English language that start with the letter T. You may have psyched yourself out because you started thinking and you're like, wait a second, is this a trick? It feels like a trick, so I'm going to go with K. And if you did that, you ignored your gut reaction, your gut instinct, which is what heuristics are all about, right? Heuristics are that system 1 process that allow us to kind of make these intuitive decisions. So the fastest answer that you'll probably guess is T. But why is it? Why is our gut T? The reason why is because whenever we are trying to make a decision about this, we think of other examples. So we think of other examples of words that start with T. Okay, T, triangle, topography, topiary, tremendous, topic, topical, tiramisu. I don't know why those were the words that came to mind, but those are some examples. Now, if you ask me what words begin with K, I was like, all right, I got kite, I got kaleidoscope, kinesthetic, kinetic. Okay, and I'm just going to stop there instead of just wasting your time trying to guess. The point is, it's much easier for us to think of examples that start with T. There's more of them readily available for us to think about, and so we go with that instead of K. It's much harder to generate examples like that. Now, same question. Are there more words in the English language whose first letter begins with K or whose third letter begins with K? So think about that for a second. Which one do you think, there are more of, where the first letter begins with K or the third letter is K? The best answer here is actually the third letter as K. Most people will say that the first letter is K, that one they can think of more, and so that's going to be the best answer. And the reason why is because it's much easier for you to think of words that begin with the letter K than think of words whose third letter is K. So, for example, I named all of those that started with K. Can you think of any whose third letter is K? Maybe not, until you realize, like, oh, rake, bake, cake, take, all of those and any kind of variation that rhymes with that has the third letter that begins with K, and then whenever you start kind of conjugating them with ed or ing on that, you can see how it kind of explodes. There's a lot of words whose K is the third letter of it. It's just that they're harder to recall, so we tend to devalue how frequent we think that those are. And that's the availability heuristic. If you want to think about this in the news, so before 2020, before the pandemic, the COVID pandemic, my go-to example was that crime, everyone always thinks that crime is on the rise. And that's always been true. People always think that America is filled with crime or whatever. But from like the 70s until 2020, basically it was in this gradual decline. It's just that the news tends to report on crime, and so we think that it is everywhere around us. When 2020 happened, it kind of shot up and then has kind of been kind of up and down since then. But that's an example of availability heuristic in news, that you see it on the news, so you think that it happens around you. If I were to ask my father, like, how much crime do you think happens in a city? He doesn't live in a city, but he sees them on the news. He's going to think that cities are rampant with crime, right? So a less politically charged example here would be, which baseball team has won more World Series titles? So is it the Oakland A's or the Los Angeles Dodgers? So if you're thinking about this, at least for me, my gut is, I'm going to go with the Dodgers because I know they've won more recently and they have a good team usually. The Oakland A's, I don't know how they're doing. Sorry, no offense to you, those of you that like the Oakland A's, even though I think they're moving, or maybe they have moved, I don't remember. But the Oakland A's have won 9 World Series titles and the Dodgers have only won 7. So the Oakland A's have won quite a bit more, all things considered. It's just that they haven't won a World Series, I think, since the 80s or maybe even the 70s. It's been a long time. So those memories are less available to us. We don't remember them, and so we think that the Dodgers have won more. Another example that's maybe more salient for y'all, because I know that baseball is not super popular at Westfield. Which football team has won more Super Bowl games? Is it the Pittsburgh Steelers or the New England Patriots? Think carefully about this one. Which one is it? If you think about this one, both teams have won 6 Super Bowls at the time of this recording, but it feels at least like the Patriots have won more because we think about the Tom Brady years, right? Whenever they won so many in such a short amount of time. The Steelers were very effective in the 80s, right? And then once again, I think in the early 2010s, I could be wrong about that. But it's been a while since they've been on fire, since they've been great. And so for that reason, we tend to think that the Patriots maybe have more Super Bowl wins than the Steelers because of availability. Because of the availability heuristic, it's easier to remember those times that you may have seen some of them. You may have seen some of those Super Bowls where the Patriots won. All right, let's talk a little bit about the anchoring heuristic. This one is kind of hard to talk about, which is why I wanted to single it out. The anchoring heuristic is the idea that we tend to have a gut feeling, that we tend to make a choice, and then based on new information, we can kind of move away from that anchor point in our decision. So I'm going to, here's an example. I got a couple examples for you. This is one example that comes up whenever you start talking about research methods and the way that we test behavior. Whenever you give somebody a sliding scale to choose something on, you have to worry about anchoring. Whenever you're using Likert scales, you got to worry about anchoring. You got to worry about whether or not the way you present that scale is going to affect the way that somebody responds on a task like that. So here is an example. Let's say that you got this question on a survey where somebody is asking, how many times a day do you smile? And you see that the survey is from 0 to 100 plus. So whenever you are making this, or when most people are making this decision, they're going to look at their scale and they're going to see 0 to 100, which means that they are probably going to fall somewhere in the middle here, right? Because when most people think about themselves, unless they are depressed or pessimistic, they're probably going to think like, oh, well, I don't smile as much as everybody, and as I don't smile a lot, but I definitely still smile, so I'm probably somewhere here in the middle, right? But that would mean that basically that person is saying that they smile, which I messed up these anchors. It should be more something like, 30, 60, no, that still doesn't work. but they're going to think that they are somewhere around here because they feel average in terms of how much they smile, when in fact maybe they smile 10 times a day, and that's normal, and that's way further down, but their judgment has been changed because it has been anchored to 0 to 100. Let me give you another example. If I were to ask you which group is smarter, Hulk Hogan, Isaac Newton, or Marie Curie, that's group 1, or do you think group 2, Albert Einstein, Stephen Hawking, and Floyd Mayweather? Okay, so when people are guessing this one, usually, I ask this in class, usually people are going to go with group number 2. They go with group number 2, and when I ask why, they say, well, Hulk Hogan is not very smart. And it's like, okay, well, what about Floyd Mayweather, right? Like, both of these guys are fighters, right? Floyd Mayweather was a boxer, Hulk Hogan was a wrestler. And the other people are all geniuses, right? Isaac Newton is a genius, Marie Curie is a genius, Albert Einstein is a genius, Stephen Hawking was a genius. They're all geniuses, except for these 2 guys who were, fighters. So, for the most part, these groups are roughly equivalent. And yet, most people are going to say group 2. And the reason why is because it starts strong and then ends with someone that we don't normally associate. This one does not start strong, but ends with people that we associate with intelligence. So it has anchored our estimates for that group. Here is another example, and don't do the math here. Just try to guess. What is the product of these numbers? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's going to equal what? 400 something? 300 something? 6,000 something? What do you think? So try to just take a guess at that. And then I'm going to throw this one at you. Guess the product of these numbers. 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. So what do you think that one is? Oops, I messed up. I was going to tell you the answer. All right. The answer for the top one right here is 40,320. That is the product of this. Do you think this next one is going to be lower or higher? Most people, whenever they see this, before they try to work it out or think about it too critically, will say that they think that this one up top is a larger product than this one at the bottom. But you probably realize, oh, these are going to be the same numbers, right? These are exactly the same numbers whenever you multiply them. It's just that this one looks like it's going to give you a bigger product than this one down here. That is the example of anchoring, because we start out with the high numbers here. This one starts out with the low numbers. So if you're presenting somebody with bad news, maybe, it can be helpful to give people the good news first, because that is going to anchor their feelings towards the decision that they have to make, instead of if you started with the bad news or the low quantity math down here. All right, there are a couple of other heuristics that I want to talk about. If you were to just go online, if you were to go to Wikipedia or whatever and just look at heuristics, you'll find there's a slew of them. There's a lot of heuristics. We're not going to go over all of them because, it would just take forever. But I do want to highlight a couple of them that I think are really interesting. We got the recognition heuristic. The recognition heuristic is that if you have one item and you recognize what it is, and you have one that you don't recognize what it is, we're going to tend to think that the ones that we recognize are a higher value. The book gives you a really compelling example of this. They use a different term for it, and I can't think of what it is off the top of my head. It's like generative something. I can't remember. I'll find it later. It's called the endowment effect. The endowment effect is basically that, had to look it up because I couldn't remember off the top of my head. The endowment effect is this idea that the things that you have are worth more than things you don't have. And the example they give there is this really cool study where they give somebody a coffee mug and they say, all right, if you're going to sell this to somebody, how much would you sell it for? And then they have another group of people where they show people that exact same mug and they say, how much would you pay for this? And the people that own the mug usually rate it as being twice as expensive as those that are making a price for it, which suggests that people feel like because I have this, it's worth more than if I didn't have it. Similar to that is the recognition heuristic. The recognition heuristic is essentially saying that things that you recognize you tend to think are more valuable than things you don't recognize. So, so I don't know if y'all care at all about music too much or music history too much, but like think about like if I were to ask you about, you know, like albums that are influential or whatever, if I were to say, you know, like, which album do you think is more highly rated by critics? Do you think it's this album by the Beatles or this album by Van Morrison? A lot of times people will just immediately go with the Beatles, right? Because we recognize the Beatles and we may not recognize Van Morrison off the top of our head. But Van Morrison has a couple of albums that Rolling Stone puts in like their top 10 or whatever. Into the Mystic, I think, is one of them. I don't really like Van Morrison, but that's an example of, like, because we know the Beatles, we've heard of the Beatles before, we tend to think that they are greater, worth more than something that isn't. That's an example of the recognition heuristic. The affect heuristic is whenever you change messages so they are emotionally charged, and then that usually persuades people more than factually framed messages. The scarcity heuristic is whenever we perceive something to be difficult to get, we tend to think that it's very valuable for that reason. And I guess if you're thinking in terms of economics, there might be some truth to this because of, you know, supply and demand. If everybody wants, you know, my phone, and there's only one of my phones in existence, people might bid on it so that it costs a lot. But really, my phone is only worth, you know, however much a Google Pixel is worth, right? It's not worth that much more. And then finally, effort. The effort heuristic is the idea that whenever we think that things that take a long time to make are worth more, are more valuable. And so if I told you, hey, your favorite author, they just wrote a novel and it took them 2 weeks to write it, do you think it's going to be any good? Versus if I said, hey, this other book that they've been working on it for 20 years. I think most folks usually will say that the book that took 20 years to write is going to be better or more valuable than the one that took 2 weeks to write. Because we think that just because something required more effort to make, that it must be better. And we see this a lot in our daily lives where, like, somebody will be like, hey, look, you know, I made this bread. Oh, I'm not trying to be mean, because I love bread, but I don't want to make anybody feel bad about this. So I'm just gonna say it, that, like, bread is kind of hard to make, right? If you try to make it on your own, bread is not super easy to make. So if I made a loaf of bread and my friend bought an almost identical loaf of bread from the grocery store, from the Big Y or whatever, and we were thinking about selling both of our loaves, I would probably say, like, oh, my loaf should be more expensive because it took me a longer time to make it, right? Even if they taste exactly the same, even if they look exactly the same, we would want that handcrafted bread to cost more, right? Because we feel like it's more valuable because there was more effort. Even though they have the same nutritional value, they look exactly the same, they taste exactly the same, right? So what I'm saying is just buy the store-bought stuff. That's not what I'm saying. But those are just some other examples of heuristics that you might see in your daily life. The final heuristic that I'm going to talk about is framing effects, and the book does talk about this a pretty good bit. So let's take a quick look at framing effects. The idea of framing effects is that the way that you frame, the way that you lay out information can influence somebody on accident. So let me give you an example here. Dihydrogen monoxide, DHMO, is a colorless and odorless chemical compound, also referred to some as dihydrogen oxide, hydrogen hydroxide, hydronium hydroxide, or simply hydric acid. Its basis is the highly reactive hydroxyl radical, a species known to mutate DNA, denature proteins, disrupt cell membranes, and chemically alter critical neurotransmitters. The atomic components of DHMO are found in a number of caustic, explosive, and poisonous compounds such as sulfuric acid, nitroglycerin, and ethyl alcohol. If I were to ask you, because this was used in a previous study where they gave a bunch of participants this and said, do you think this should be banned from public schools? A majority of people said yes, it should be banned from public schools, but the problem is this is actually water. So dihydrogen monoxide, H2O1 or H2O, is just water. But it sounds really bad because of the way that we have framed it, right? And there's a little bit of, the affect heuristic here because I'm using some emotionally charged words, right, to try to like sell you on this. But the way that it's framed is going to lead us to make an uninformed, irrational choice. Nobody wants to outlaw water in public schools, right? But because it is framed this way and made to sound really severe and nasty, it changes the way that we think about it. Here is an example that Kahneman and Tversky gave from 1981. Imagine that the United States is preparing for the outbreak of an unusual disease which is expected to kill 600 people. 2 alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of the programs are as follows. Program A says if we take on this program, 400 people are going to die. 400 people out of 600. If program B is adopted, there is a 1/3 probability that nobody's going to die and a 2/3 probability that everybody's going to die. Okay, so if we were to do the math, and if you don't believe me, you can do the math on this, basically these are going to be statistically the same. That basically what we're saying here is that on average for A, we're guaranteeing 200 people are going to live. And if we go with B, probabilistically 200 people are going to live. So when looking at this one, program A, sounds kind of scary. It's guaranteeing that 400 people are going to die, right? Here, what we're saying is that there's a 1/3 probability that nobody could die, right? Which is kind of appealing. Knowing that there's 1/3 probability that nobody could die versus the certainty that 400 people are going to die. And so most people will go with program B for that reason, even though statistically they yield the same outcome. If we change this up a little bit, you can see how this might change the way that we think of things. So this is one example. And also I should say, the other way to think about this is like we could have phrased this as if program A is adopted, 200 people will live, right? And then we could frame this as if program B is adopted, there's 2/3 probability everybody will die, and 1/3 probability that 200 people will live, right? That might actually change the way that we choose it. I think if we framed it that way, more people would choose program A, which is, in fact, actually what Tversky and Kahneman showed in their original paper. They reversed those. Here's another one from that paper. So we got problem number 1. Assume yourself richer by $300 than you are today. You have to choose between one of these gambles. Either you are sure to gain $100, or you have a 50% chance to gain $200 and a 50% chance to gain nothing. So basically what we're saying is that you're starting out here, you're starting out $300 richer. And then we can either make sure that we get 400 or we can gamble. And if we gamble, we have a 50% chance of gaining 200, which means that we gain 500. We have a 50% chance to gain nothing, which means that we would have 300, which means that the average is going to be about $400, which is exactly what bet number A is. So there is no real difference between these two options. However, people choose them differently. People choose them differently because they will go with A. People will go with A because they're worried about losing something now that they have it. Let's look at problem number 2, because this is slightly different and it illustrates a similar point. Assume yourself richer by $500 today. You have to choose between a sure loss of $100 or a 50% chance to lose nothing and 50% chance to lose $200. So if we are looking at this, all right, we got $500, and so for number 1, we know that we're guaranteed $400. Okay. What about this next one? A 50% chance to lose nothing, so that'd be 500, and a 50% chance to lose $200, so then that would put us over at 300, which again means that on average this gamble would yield us $400. In this case, people are much more likely to go with B in this case, even though, as you just saw, these mean the exact same thing. That basically what we're saying is that problem 1, either option is going to give you $400, and for problem 2, either option is going to give you $400. People choose very differently here. More people choose A when framed this way, more people choose B when framed this way, and that is framing effects. All right, let's take a quick break. We're going to enter the final 30 minutes in just a moment where we talk about reasoning. All right, welcome back. We are talking about reasoning now. So let's talk about reasoning. On the exam, I am not going to test your logic abilities. So don't worry about that. So if you're somebody who's naturally bad at logic, I'm not going to teach it to you. But and I'm not saying that to be snarky. I'm saying that so that you don't have to worry about it, because this is one of those things where it's like some people, they really struggle with this stuff, and I don't want you to feel like you're going to be tested on this on an exam and you might make a bad grade on an exam because you can't do it. Does that make sense? But I will say, as a quick aside, that after I graduated from college, when I was in grad school, I remember taking one of those like free classes you can kind of find, like Stanford or MIT or whatever might have like an open course that you can just kind of watch videos and listen to podcasts and see some of the assignments. You don't get course credit for it, but you kind of get to do it. I took one on symbolic logic and about inductive versus deductive reasoning, and it's one of the best courses I ever took in my life. Like kind of a life-changing type of thing. Totally changed the way that I thought about decision making. So I highly recommend this stuff. If you're not familiar with logic and stuff like that, definitely check it out and get acquainted with it, because it might be one of those things that you are really good at and just never knew. And if so, it's kind of a superpower. All right, so let's talk about logical reasoning. So logic, you've probably seen things like this. Is called a syllogism. A syllogism is usually a three-statement kind of phrase right here, where you have two pieces, two precedents, and then kind of a conclusion, an antecedent and then a consequent. So what we're saying here is all M are B, all D are M, therefore all D are B. This is true. So this is logically valid. This next one is too. All X are Y, some A are X, therefore some A are Y. Then finally, some A are not B, all A are G, therefore some G are not B. And if you're like me, when you receive this, you're like, oh my God, I guess that's right, I don't know. So what I would recommend as we start going through this is, much like when we were talking about statistics and probabilities, that it can be helpful to kind of visualize the probabilities, and that most times, most people's estimates are better whenever they visualize things, and just like what we did here, right? Like, there's a reason why I stopped and kind of got the $400 mark here, because whenever we realize that the 400 is the outcome here, then we know how to respond to it, right? We're not just relying on system one. So here, the way that I would encourage you to do logic, at least beginning, is to substitute these letters with some kind of object, something that you can imagine. That makes it a little bit easier. So, for example, if I said all M are B, so I'm going to say all cats are mammals, and all dogs. Wait, hold on. So I got all cats are mammals, and all, let's say tabbies, like a tabby cat. Is that how you spell tabbies, or do you got to do the IE on that? I don't know. All tabbies are cats, right? Because here what we have is M here, and we got B here, we got D here, and then we go back to M. Therefore, all tabbies, sorry about the spelling. All tabbies are, and then what's B, are mammals. And that's true, right? Like, we know that's true. And so here the logic worked out, right? So like, and I could do this for the other ones and give you examples of that, but you have to trust me for the sake of time. All right. So the next thing we're going to talk about is one of those things that kind of trips up a lot of students, and it's called the Watson selection task. The Watson selection task is also in the book called the 4-card task. They mean the exact same thing. So if you see that in your book, it's just referring to this. And this is really kind of tough because it kind of picks up on what we see here with logical reasoning. So if a card has a vowel on one side, then it has an even number on the other side. That is the hypothesis. This is the idea that you are testing. Cool. What cards do you need to turn over out of these 4 to demonstrate that this rule is in fact correct? So, and I realize I spelled turn the way that we pronounce it in South Georgia to prove this rule. So here we go. This is our hypothesis up here, and here are the 4 cards. Now I know you're tempted to just turn them all over, right? But for the sake of this task, you're supposed to only turn over the ones that you need to turn over to verify that whether or not this rule matters. Some of these, if you turn over, it will not change whether or not this rule is true. Okay, so here we have, it's an if-then statement, right? So if something happens, then something happens. That is important. This is the antecedent, this is the consequent. So if this thing is in place, then we can find this other thing to be true. So with that in mind, if a card has a vowel on one side, when we turn it over, it has an even number on the other side. Which of these cards do we need to turn over to verify the truthiness of this statement right here? Is this a hypothesis that we can accept, or do we need to rule it out? So which of these would you choose? I will let you decide first, because go ahead and decide. Pause it if you need to and think about it. Write down your answer, and we'll verify right now. So, yes, I know you had your eye on A, right? You were thinking about A, and that is right. If you turn over A, and I think about 95% of people will choose A as a card to turn over. And here's the reason why. Because if we turn A over, because it is a vowel, and there is a number 6 on the other side, or if there is a 2 on the other side, that's okay. No big deal. If we turn it over and there's an odd number, then this statement is wrong, right? Then the statement is false and is a bad hypothesis. So yes, we definitely want to turn this one over. But what about the others? So if I look at this one, even number on the other side, lots of people will choose this one. However, you do not need to turn it over. This is not one of the ones that you should choose, although a lot of people choose it. I want to say about 60% of people, off the top of my head, I think it's about 60% of the population, maybe 65, want to turn this one over. But I'm going to show you it doesn't matter if you turn it over or not. So if a card has a vowel on one side, then it has an even number on the other side. That's what we're testing. So if I flip this over, and there is a vowel, if there is an A, cool. That means that this hypothesis seems to be true. But let's say that we turn it over and there's not a vowel, that there's a B, for example. If a card has a vowel on one side, then it has an even on the other side. Well, that doesn't really matter to this. It doesn't say only cards that have vowels on one side have even numbers on the other side. It doesn't say that at all, right? And so we don't actually need to flip this one over because it doesn't matter if it has a vowel or a consonant. It doesn't change this statement. It doesn't change this hypothesis. All right, so we don't need this one. What about J? J is usually is not a commonly accepted one because we don't see anything about consonants up here. So if we flip this one over and there is a 2 or a 3, I don't think it matters, right? It doesn't matter. It doesn't change this hypothesis and whether or not it's true. But 7, on the other hand, does. And here's why. If we turn over 7 and there's an A, then boom, we can disprove this. This is considered incorrect, right? Because if I turn this over and there's a vowel, then what that means is that card has a vowel on one side and an odd number on the other side. And so it's in everyone's best interest to turn over only the A and the 7. These others just don't matter. They don't matter regarding the logic of this statement. So those are the ones. I was close with these numbers. It was 90 and 25%. 25% of people, so less than half of people choose this. If you chose number 7, congratulations, you're in the minority. Most people get this one wrong. Most people get this one right. And then oftentimes you'll get people choosing 6, but not a lot of people choosing J. So here are some examples of good logical reasoning. So if A is true, then B is true, and you find that B is true, therefore A is true. That is what we call affirming the consequent, where we find out that B is true, and so if B is true, then we can accept A. And so that's good logic. Denying the antecedent is also good logic. Hold on. Wait, let me... Actually, no. I'm wrong. So this is how confusing this stuff is. That this is actually wrong. Like, this is bad logical reasoning. These are logical fallacies. And I was playing right into it because it sounded correct. But you can apply the same text that we just did over here to this, where basically we're saying, if something is even, then it needs to be a vowel on one side. Where basically, if you find that B is true, it doesn't necessarily mean that A is true. Likewise, if you find that A is not true, it doesn't necessarily mean that B is not true, that they can be independent that way. And so you can kind of see how basically the textbook is going to give some examples of this in writing, where you can kind of see how these don't really work. All right, so, but again, this is hard stuff, and this is the reason why people are not very good at using logic, is because when we see, including myself, stuff like this up here, this stuff looks right. But whenever we start applying actual examples, you can kind of see where it goes wrong. So if the object in my hand is a frog, then the object is green. The object in my hand is green, therefore it is a frog. We know that doesn't make sense, right? So this is why it can be helpful to kind of populate some of these letters with examples that are concrete to help make that clear. All right, but you got to be careful whenever you do that, because as we're going to see, people like to try to trip you up with this. And I can't believe this study is so old at this point. This is from 2003. But it's a very important kind of review article that talks about the belief bias effect. Just a quick reminder, because the belief bias effect is, this article really kind of talks a lot about the dual process theory. Basically, just as a reminder that whenever we are talking about really fast, instinctual, kind of automatic based guesses, then we're talking about state 1 or system 1. If we're doing something slower, then that's system 2, and that's what Kahneman called lazy, right? For logic and reasoning, we got to use system 2. We got to use system 2, part of over here, the reason why logic can be difficult is because system 1 kind of wants to just jump to conclusions, right? We just want to basically, not have to wake up this slower system 2 in order to get the right answer. And so this explains why a lot of times our gut instincts might be correct sometimes, because system 1 might get things right, and then we use system 2, we wake it up, and it talks us out of the correct answer. One of my favorite examples of kind of this battle between System 1 and System 2 comes from this article that looked at teaching evaluations. Now you understand why I found it interesting. It's because I'm a teacher. Basically what they did is they had one class sit with a professor all semester, and then at the end they had teaching evaluations, and they looked at the teaching evaluations. There was another group who had never seen this professor before, but for 30 seconds they showed them a clip of them teaching, just a 30-second clip of them teaching, and then asked, all right, we want you to try to rate this professor, how well you think they would be if you had them for a full class. And what they found is that there were no differences. It didn't matter if you were with that professor all semester or if you were with them for just 30 seconds. That 30 seconds was enough for us to lock in and make our minds up about the effectiveness of that teacher, which speaks to the effectiveness of good first impressions, right? But basically what I'm saying here is in that case, our system 1 can be right, where we have a gut feeling about a teacher or a professor, like, oh, I'm kind of worried about this. And then, yeah, it turns out you didn't have a good semester because system 1 was trying to let you know about that. So system 1, even though it is fast and kind of instinctual, and we've been talking about how it leads to incorrect decisions all chapter long pretty much, I do want to point out that there's a lot of research to show that sometimes your gut instincts can be right. It's only whenever they are wrong that we really notice them, because so much of what we do in life is this system 1 kind of thing. All right, so let's take a quick look at the belief bias effect and wrap up this chapter. So the belief bias effect is this idea that in terms of logic and reasoning, people are not very good at doing that, right? Which we already established. But people will trust bad logic when it confirms their beliefs. And this is why I wanted to have this at the very end of the chapter, because you can see how it's connected to what we talked about at the beginning of the chapter when we were talking about confirmation bias. So let me so I'm going to walk through each of these and, just to kind of unpack this, because there's a lot of info here. So basically, Evans, this author from the study, he came in and he asked participants to read these syllogisms, these logical statements, and then say whether or not they thought the conclusion was logically sound. So basically, they have to look at these first two pieces, look at the third piece, and then judge whether or not this third line is correct based on the reasoning in this second, in the first two sentences. Okay, so that's all that they're doing here, and so Evans, what you're going to see here are that there are two valid arguments and two invalid arguments. But what Evans was really interested in is he was interested in how if you just take that final sentence and you make it something believable, that you can change how likely someone is going to agree with that logic. So logic is not something that you can agree with or disagree with, right? Logic is just logic, it's just reasoning, right? That there is absolutely a correct answer or absolutely an incorrect answer. It's not one of those, well, I see it both ways. It's like it is or it isn't. So here, let's look at the first one. This is a valid argument, so the logic holds up, the logic is correct, and it has a believable conclusion. So the believable conclusion is something that if you were to read it on your own, sounds believable. So let's do that first, before we even unpack this. Some highly trained dogs are not police dogs. I believe that. I know that because I have some highly trained dogs and they're not police dogs. So that's a believable conclusion. Now if we look at the argument, no police dogs are vicious, some highly trained dogs are vicious, therefore some highly trained dogs are not police dogs. So this is a valid argument that the logic is okay. Now some of you would probably maybe disagree with this first piece, right? But that's not what we're doing here. We're not agreeing with the conclusions, we're just looking at the logical argument. And if we look at just the logical argument, then yes, this is correct. And what we find is that people in that position, when they have a valid argument, and it's a believable one, believable, green is believable. I think that may have got cut out. And red is an unbelievable conclusion. So yeah, people, was this about 87% or so? 87% got that correct. That's great. Let's look at the other valid argument. So this other one. No nutritional things are inexpensive. Some vitamin tablets are inexpensive. Therefore, some vitamin tablets are not nutritional. Okay, so that is an unbelievable conclusion, right? So what we're saying is that some vitamin tablets aren't nutritional, but if they're vitamins, then vitamins are by definition nutritional, correct? Right? Am I wrong about that? So this is an unbelievable conclusion. Some vitamin tablets are not nutritional. That means that some vitamin C's don't do anything for you, right? But we know that's not true. So this is a valid argument. If we were to unpack the logical reasoning here, it would work. But this is an unbelievable conclusion. So if we were to look over here, this is what we see. We move down to below, this is what, 58% or so? So almost a 30% jump just because we look at a believable conclusion versus an unbelievable conclusion. And that's the belief bias effect. That whenever you have a piece of evidence where the ending conclusion confirms your beliefs, you're more likely to say that the entire logical argument was logically sound and correct and accurate. Although that's bad, right? Like, basically what I would be saying, like, all right, so something that I agree with. So, like, Twin Peaks is a good TV show. That's, call back to the first video. So if somebody said, like, some TV shows are Twin Peaks, and some TV shows are the best ever, therefore Twin Peaks is one of the best TV shows of all time, that logic does not hold up. But I believe the conclusion, so I'm more likely to say, yes, that's right. That looks great on you. I heard that. I'm going to... I felt seen or whatever. And so I'm going to go with that. I like that. Even though that's incorrect. Even though that's bad. Let's take a look at the invalid arguments now. So these are invalid arguments, which means that the logic does not hold up. And so all of these should be very close to the bottom, right? Because they are all invalid. And so if we look at this, let's look at this last one first. So an invalid argument with an unbelievable conclusion. No millionaires are hard workers. Some rich people are hard workers. Therefore, some millionaires are not rich people. That, by definition, doesn't make sense. If you have $1 million, that's a lot of money. That makes you a rich person in my book. And so this is an unbelievable conclusion, and this logic doesn't work. And so about 10% of people said that it was accurate. So I don't know what to say about those 10%, but this is not good, right? Like, it should be basically be 0. But that's fine. And this is the lowest of all the conditions, so that's okay. But if we look at this right here, no addictive things are inexpensive. Some cigarettes are inexpensive. Therefore, some addictive things are not cigarettes. If we look at that conclusion, some addictive things are not cigarettes. That is absolutely true. Coffee is addictive, and it is not a cigarette. So that is a believable conclusion, but this logic does not hold up when you unpack it. And yet, people with basically 70% of everybody said that this was a valid argument, that this argument was good because of that, because the conclusion was believable. So the take-home message from this slide right here is that whenever somebody gives you a bunch of evidence and ultimately the conclusion is something that confirms what you believe, you should be cautious about it, because it's very easy for us to naturally overlook the logic or the actual evidence behind that statement and just go with it because it confirms what we believe. And that's an example of system 1, that instinctive system kind of messing with us and getting it wrong. All right, and that's it. Yeah, so we are done. Thank you so much for putting up with this extra long jumbo chapter. And I slimmed it down. You can see, like, all these slides that I cut out, I cut these out because I was worried I was going to go too long, and I did. So again, thank you so much for being here, and I will see you on chapter 13 when we talk about problem solving. See you later.